So maybe I should start also, Pavel, because unfortunately the weather changed and it's raining now. So that's a quick weather update. But what I will present now, I'll put it on presentation mode. Okay, so I would like to present now a tool that we created with the whole community to visualize the air quality measured by a mobile sensor. So we call this tool DEVD, but that's a short name, but the long name is Dynamic Exposure Visualization Dashboard. Let me go back to this aim. So the visualization of air quality measured by a mobile sensor along a route. So we have a 4-step approach. So we start with measuring the air quality with a mobile sensor. And meanwhile, in parallel, we also recorded the trip geometry. So the position and the time at any moment. And we use for this the DEVA trip recorder that, that Oliver was explaining just before me. So the idea is that we map the first 2 measurements that we did in point 1 and point 2 together in a compare data manager. And then we visualize the results in a dashboard. And this visualization will be like on a map. We also will show some graphs to understand the data a little bit better, but there's also room for comparison of different trips, and I will show you some examples at the end of this presentation. But let me start with the measuring sensors. The sensors that measure the air quality. The sensors that we use are the SODAC sensor in the first place. As you can see on the picture, this blue device. So this is the mobile version. You also have a static version of the SODAC sensor, and the sensor is measuring fine dust. So it's making difference between fine dust particles from 1 to 10 micrometer diameter. It also has an internal GPS system, this SODAC sensor, but you can also immediately read the air quality roughly through a LED light. As you can see in the picture at the right on top, it's a blue light. This means that air quality is really very good. The picture below, there's an orange curve saying that the air quality is a bit less good. Orange, if the color is orange, then the quality is not so good. And then if it's red, then, the air quality is really very bad. What we also want to use is the BC meter sensor. So this is a sensor that's measuring black carbon. It has no internal GPS system. Until now, we only have static measurements till now. So as you can see in the graph below, this is a comparison with other BC meters that exist. And you can see that the quality of the data that are measured by this BC meter are really very good and comparable with other BC meters. But this is still an ongoing experiment. I just want to mention it also that we are testing it at this moment. So how does it work? So we have this SODAC sensor. You can mount it on your bike or on your motorbike, or you can take it with you on another vehicle. It's very easy to mount it also on your bike. You can also fix it like on your back if you're walking. It's like with a silicone sleeve that you can put over it. You can protect it also a bit from the rain, but then it starts measuring also. So this is how you activate this device. Secondly, we use this DEVA trip recorder, as Oliver explained, to register the trip geometry. So at each moment you have the XY position, and you also measure the time. We also measure or we gather some metadata. So we also like to ask to the people in what pilot region they are. We also ask them what transport mode they use. And of course, they also need to insert the sensor ID, a unique ID, so we can make the connection between the DEVA recording and the recording that was done by the air quality sensor. So maybe I also added this slide because, if you develop like a solution like this, there's quite some tweaking that needed as well. So the first thing that we did, like if you look at the corner, the upper corner at the left side, you can see a trip. It was one of the first recordings we did. So it was really very rough, very coarse. But then later in the project, we could see that the trips were recorded much better. Only here in the second image, there were still some corners that were cut off. If you look at the blue lines and you compare it to the red lines, which are the real trajectory that we did, then you can see it's getting better and better. And now at this moment, we have like a very, very good trip recording that is done. So that's one thing. We also made some updates. We updated the measuring frequency according to the transport mode. Of course, if you have a very fast moving vehicle like a car or a train, then we need much more frequent measurements. So this is also something that we changed. We also made some updates to save battery and bandwidth. So we made the data a bit more compact, and we also reduced the bandwidth by just making less contact with the server, just by sending data in a bit more blocks. There's also a lot of usability updates that we did, and this is shown by the screenshots at the lower left corner. And here you can see in the beginning, we had like a recording where buttons were very close to each other. It was very difficult to use, especially if you drive a bike on a bumpy road. You can imagine that it's difficult to make a difference between different buttons. So we made some updates, and this is what you see next to it. Buttons a bit more far apart, very hands-on information that you get on your screen. So huge updates. And maybe, well, finally, also something that we did, we tested in different countries. So we took the sensor with us, and we did some measurements in the UK, in Austria, in Spain, France, Germany, Italy, the Netherlands, Bulgaria, and Belgium. And this is like we also tested on different locations. Like here, if you look to this picture, we tested it indoor, where you can see very bad air quality measurements because there was an open fire in the neighborhood at Christmas markets, for example. This is really the case. Okay, but now that we have this information from DEVA and we have this information from the SODAC sensor, then we can put together these data sets in the data manager of Compare. So these data are merged, and then afterwards, the DEVD, so the dashboard, can read these data from the data manager. And then we come to this final part where I explain a bit more DEVD, how it works. So this DEVD visualizes the air quality along a trip or a route. It also allows filtering, interpretation, and comparison. We have maps and graphs. We will also show the exposure and the inhalation. But now I go a little bit more in depth. But if you like, you can use this QR code that you see on the screen. And with this QR code, you can immediately see the dashboard in the real life environment. So, and this is the first example. So at the right, you see a screenshot from the dashboard that we made. So on top, you can see a series of filters. You can filter your data because there's a huge data set. For now, for example, we have 910 measurements done till now. So the list here with all the trips will be very long. So you can filter them. You can choose, well, I only want to see trips that were made by a bike, that were also registered only in Belgium, for example, or in Berlin. And I only want to see SODAC sensor results and not black carbon results. So these are the filters that are used. And then we have also a map where you can see your trip. And if you could look carefully, you can see different colors. And the colors, it's like a color code that's also explained here in the legend. With this color code, you can see the air quality immediately, in more like classes. So you can also click on each segment and then see the information as well. But then we go to the graphs that are a bit more interesting. There you can see in function of time or in function of distance how the air quality is changing during your route. And well, okay, this is like a route that was done close where I live. So I made like a bike ride to the station, and there you can see the colors are all green, so air quality is good. You can also see here in the lower corner, this orange line that you see, these are the WHO guidelines. Well, the measurements didn't exceed at any point the WHO guidelines, so we can say that it was like a healthy route. What you also can do, and this is also a test that we did, I will just give some examples now. What you also can do is like measuring on a train. This is a measurement that we did. Like this is the trip recording that was done. And you can see that the air quality was also good on the train. But of course, if you measure in the train, the air quality is quite constant. I thought by putting like the sensor on the vent system of the train that it would take some air from outside and measure the air quality from outside. But no, it was just the air quality in the train. But what is really very interesting is also that you can compare two bike rides. This is one trip, this is another trip to one point. You can see which of both trips are most healthy, for example. You can also see that one of the trips is now exceeding like this WHO guideline, but that quality there was not so good. And I remember also that that was a point where there was wood burn in a house very close by. These are two other graphs that we also include in our dashboard, and this is telling you something about the exposure. You are exposed to contamination in the neighborhood, and this is shown like in a more like cumulative way. So it's adding up, and at the end you have exposure like this. This orange line is also the WHO guideline, and you can see for both trips we're under it, so that's good. And this graph, also nice, this is the inhalation of a pollutant. So you inhale, of course, and you inhale like fine dust. And at the end of your trip here, at this point, you can see that you, for example, inhaled 47 micrograms of fine dust. And you can make a comparison with other trips as well. So this makes this very nice. But for this inhaled dose, well, of course, it's dependent on gender, but also on age, and of course, the activity that you're doing. If you're walking very slowly, or if you run very fast, you start breathing more and you inhale more of the pollutant. And this is also something that you can set up with drop-down boxes to have a clear idea about the air quality. We can also compare two regions. So here we compare a region in Berlin. This is the green line with some measurements that were done in Flanders, where you can see like the pollution is worse in Berlin, but for a certain point, of course, it's not in the whole Berlin. And then finally, this is also something I want to show, and that we can do just by, we had some sensors, SODEX sensors that were not working correctly anymore. So we took all these sensors, there were 4 of them, and we took the same route, but at the same time, and with these 4 different SODEX sensors. You can see that these measurements are really very different. And that's why we also said that, well, they were broken and they were replaced by others. So I think that's briefly what I wanted to say about this tool, the DEVD tool.